Alright, hello guys, welcome to end of course review number 2, worksheet number 22. I'm going to start this off again by the same thing I did in the last video. If there's anything wrong with these solutions, please let me know and I'll go back and fix it. Because again, I've only learned maybe a third of these things when I took the class in the previous semesters I SI'd the class. When Dr. Duncan came in and just made my job like 10 times harder for me. So I apologize if I'm making any mistakes, and please let me know for the sake of me and hopefully anybody else that looks at it and then gets it wrong on the test and says it's all my fault. No. Yeah, anyways, just let me know if I do anything wrong. But here we're going to go Dijkstra's algorithm. If you remember how to do this one is to kind of, we're going to be finding the lowest path from A or from this tree that we're building to the next node. So the cost from A is obviously we're going to go kind of 0 here. And this one will kind of have like a path from null. It'll have a length of 0 and coming from a path of null because it's the root. And then now we're looking for what's the next lowest path. B has a length of 4 from A, and G has a length of 7 from A. So we will do 4, comma A for B, because it's coming from there. And we're going to update this path, like so. I'm also going to make a note, we're going to have 7 here, just for the length. We're going to keep track of the shortest length of the paths from A. So B was 4, G was 7. All right, next we need to find the next lowest path, so we can add on the next one. So C is going to be 9 away. It's going to be 4 plus 9 away from A, so that's 13 away. G will still be 7 away. H will be 24 away, so we can add that on, but that's obviously going to change later on. Next lowest is obviously G, so we're going to connect to that. Yeah, it's a little bit harder to do this in Word. And there goes my dog barking off. All right, so now we have, I probably should have just left that 7 there. So now we have 7, comma A. Alright, and then now we can continue adding on. So now H will be just 7 plus 1, which is not 24, it's 8. So this can just change to 8 now. And then everything else stays the same. So the next lowest path here is obviously H. So we're going to connect H coming from G. So we do G here, and then we connect to this path. And then now we can update all nodes in the reachable distance. E is now 8 plus 1, which is 9. Right there, and then I right here is 8 plus 3, which is 11. All right, so the next lowest path is obviously E, so we'll do 9, comma H for that, and then draw our path from H to E, like so. And then we can update everything, so now D becomes 19, which is 10 plus 9 there. F becomes 24. And then I is, well, it's 14, but 11 is better, so we're just going to leave 11 there. And then C is now 9 plus 2, which is 11. So now C is actually easier to get to, so we can just do this and make it an 11. So now the next lowest one is between C and I. We're going to go alphabetically. C comes first alphabetically, so we're going to go with C first. And I don't know if that's your class convention. I don't know what your class convention is. Never heard of it in my life until tonight. And it's a little late to message Dr. Duncan. So we're going to go like this alphabetically. 11, comma E, because it's coming from E. So 11, comma E. And then we fix up that path. All right. And then next we have to update everything. So now this can actually become 17 here. D becomes 17 here. So 17... and then everything else stays the same. Yeah. All right, and then next lowest reachable is I here, 11. So I will be, which will be 8 plus 3, it's coming from H. So we'll do 11, comma H here, and then create this, add this branch on, update our paths. So this is now 11 plus 12, which is 23. So this can actually change here. So this becomes 23, and then everything else stays the same. Yep. So the next lowest is D here, 17, and that is coming from C. So it's 11 plus 6 here, so that's coming from C, so we add this on. And then now F can become 22, because 17 plus 5 is obviously 22, and that's less than 23. So now that's 22, and now that's just the last node we have left to add on. There's no one else to add on, so that's going to become 22, comma D. And we add it on right like so. Now we have to do a tree of shortest path lengths. Now I'm not going to do the bubbles here just to save time, but A will obviously be the root, and then B will come to the left of it. G comes to the left of that. Oh, that's a little high. G comes right here. And then coming off of, B has no more children coming off of it, but G has H coming off of it, so we add H coming off of it. And then we add E and I coming off of it. So I'll put E to the left here, I here, just by their paths, because E came first with 9, and then it was I with 11. And then I has no more children, so we don't have to worry about that. And then we have C coming off of E, so I'll add on C here. And then we add on D, and then F. D, and then F. And then we connect all this. So here, 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 boom. Yep. And then between all of these, if you wanted to add their weights in, you would just drag like between G here, this would be length of 7, this would be length of 4, G and H would be a length of 8, or, well, it would be a length of 1, but to get to H would be a length of 8, and then to get to E, it would be another 1, to get to I, it would be 3, and so on and so forth down the line. And this would be our minimum spans here. I'm actually just going to finish this because I have OCD. 2, 6, and 5. And there you go, just like that. Alright, now we're doing Huffman coding for this string. The entire string, including this space right here. So just watch out for that, because in every tutorial I saw, they included the space in the Huffman coding. Little space was a character. So we're going to go through that entire thing, and we're going to keep their caps. And there's no, I'm not providing you with a table yet. You have to create the table on your own. So we're gonna create on the side here. Just type out all the letters you see in that string, all the unique characters. We'll just, I don't know why I made a text box for the space. It's not even gonna show up. So we'll put W here and we'll leave substantial space there so we know what exists. R, L, and then D. And then we count how many characters of each are in. So H has one character. Gosh dang it. Well, that'll be there. E has 1 character. L has 3 characters. O has 2 characters. The space has 1 character. W has 1. Dang it. W has 1. R has 1. Why is there an L there? What am I doing? Go away, L. There we go. And then D has just 1. So it's not a fairly exciting tree, but it's still something to work with. Alright, and then now we have to create our, now we have to kind of create all the nodes from this. So I'm going to go ahead and do that real quick. Alright, I have all the letters here spread out as I should have done in the first place, but we have our space here, and I got rid of the capital H just for ease of sake. Alright, and then now we need to start doing our Huffman coding. Now if you remember, we kind of go left to right, adding these guys in together. So D and our space here, which I just have as single quotes, that all becomes one node of size 2, and they both become its children. I remember how hard this was now to get the tree going properly in Paint. Alright, so it becomes something like this, and then 2 becomes a node that will go in between these 2 guys. So let's just move these guys over here. So they become a node, and then same thing with E and H. They will become a size 2 node as well. So this becomes size 2 here, and they will go down here. And then we have R and W, which will also become a size 2 node here, like so. And so 2 becomes into it, and then these are all the children of these 2 nodes. And then we have all of these 2 nodes, which are in a list here. Let me kind of fix this here real quick. So we have 2 there, we have 2 here, and we have 2 here. Alright, so we have all our 2s. We're gonna go with our O right here just because it's not a it doesn't have a guy yet. So we're gonna add it in right here and put, this is just for ease of, you know, formatting this. We're gonna do that. Make this a 3, and then make that its left child, and this 2 node its right child. And that way, this is brilliant of me. That way we can just keep it right there. We don't have to do anything. Alright, and then these 2 right here, they will become a size 4 node. Or, I mean, yeah, size 4. 2 plus 2 is 4. That's brilliant thinking by me. See, we don't really do adding anymore, so I've basically forgot how to add over the years, and then it's like SI in this course has brought back all these different things to me, and it's really something else. So those guys go over there, and then we can add these two size 3 guys into a size 6 node. This goes up here, becomes size 6. Then we have left and right. And then we can combine the 4 and 6. Now 4 will go to the left of this, remember? Because 4 would end up being here, and then 6, and then you would combine the 2. So you have to keep these lists kind of in order. So we have 4, and then 6. And then 4 plus 6 is, what is it? It is 10. So this comes up here, and this becomes a 10. And then we have left and right child. All right, now if you remember, if we go left, it's a 0. If we go right, it's a 1. So I'm going to label all these. All the left branches will become 0. All the right ones become 1. 0, 1, 1, 1. I love how easy it is to create ones. Why do I always do my zeros like that? If you've seen my videos, you know I always do those weird, like, curly zeros. I don't know. Oh, that's going to get confusing right there. Don't worry about that. That's just a 0. All right, and then we make our chart. We can just use this over here. So H will be 1, 0, 1, 1. So H will end up being, oh, this is way too big. What was it, 26 here? Okay, so H will end up being 1, 0, 1, 1. E will be, let's bring that down. E will be, let's see, where's E? 1, 0, 1, 0, 1, 0, 1, 0. All right. L will be, where's L? Where are you, L? How do you lose it? Oh, you're right here. Okay. 1, 1. So L is just 1, 1. O is now, where's O? O is right here. So it's 1, 0, 0. So that becomes 1, 0, 0. Our space here is 0, 1, 0. So 0, 1, 0 is our space. Then we have W. W is right here. That's 0, 0, 1. 0, 0, 1. R is 0, 0, 0. I didn't do that branch. I just realized 0, 0, 0. And then D is 0, 1, 1. 0, 1, 1. Yeah, I forgot I didn't do this. Here, this will be 0, and this will be a 1. It's like, okay, so I found a mistake in the video when I was doing this. I'm just going to redo this part. But basically, we are now encoding this string using these numbers here. So this one's very straightforward. If you want to do H, you do 1, 0, 1, 1. And then for E, we do 1, 0, 1, 0. Then for the L's, we do 1, 1, then 1, 1. Then O was 1, 0, 0. Now for white space, we do 0, 1, 0. Then for W, we do 0, 0, 1. O, we do 1, 0, 0. R, we do 0, 0, 0. L, we do 1, 1. And then D, we do 0, 1, 1. And then that will hopefully be your final string. Actually, that's kind of small for you guys. Let me just make that a little bit bigger. But hopefully this is correct. Hopefully I'm not going back and making it wrong a second time. But yeah, that should be your final string. All right, time for everybody's second least favorite algorithm. Or at least this is my second least favorite algorithm. I think, I don't know. I just remember the video I did it on. I fucking hated making that video. But anyways, first we're doing brute force. We're not even worried about KMP. So brute force method is going to take, it's going to take a lot of space here. But basically, you start with index 1 here, and index 0, whatever you count it as, and you just keep on matching our pattern string. Our pattern string is A, 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 B, B. So we keep on matching B, A, 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 B, and then when we get to here, we have a mix match. So then we go all the way back, and then just kind of move up 1. And that's kind of how brute force goes. We just go A, have a mix match, then we go here. A, have a mix match, then we go here. A, have a mix match, then we go here. A, have a mix match. A, have a mix match. Oh, gosh, dang, I didn't have enough rows in this. A, mix match. Yeah, this is going to take, dang it. Yeah, screw it, I just made the whole table. I don't care. So we just keep on going brute force method. A as a mix match. Then we go here. Oh, yeah, finally another A. So we go A. B, we have a mix match. And I go A, and then B, and then B, and then I needed 3 more rows. Dang it. What am I doing? But anyways, yeah, and then we get our max. And so this is what it would take for the brute force method. So, yep. All right, and then now we have to do the KMP algorithm. If you remember, we have our pattern table up here and then our long string down here. And I'm going to be trying to follow the way Dr. Duncan does it on his worksheet. Again, if it's not correct, please let me know. So just go over the rules again. If I is equal to j, so I will be following this long string, j is following the pattern string. If I is equal to j, we move them both forward by 1. If I does not equal to j, then, and if j does not equal 0, we move j back to where this index says in this table. And then if j is equal to 0, then we just move I forward by 1. So here we're going to start. This row will indicate which index we're on for I, and then we can follow this up here for j, this table up here. But anyways, if you forget how to do it, go back and watch the other video. These videos are going through Office a little bit faster. So we're going to go A, then A, then A, then B, and then when we get to here, we hit B, and we have a mix match. And now B, if we look at this table, you kind of have to look at the diagonal. We're at this B, so we have to go back to index 0. It's at a weird, I know it's weird, it's a diagonal. So we kind of have to go back all the way to index 0 here. But we can start just right here. We don't have to go all the way back to here in the brute force method. We can just start right here at A. So we go A, and then we go A, and then we go A, but it's a mix match. Now, since we're at this A, we can go back to just this one right here. So we don't actually have to go all the way back. We can just start A here. Start A here again, but it's a mix match again. So now we have to go at the diagonal all the way back to index 0. Now when we match at A, this time j is equal to 0, and so we move I forward by 1. So we move I forward by 1, we go to here. It's a mix match again, but j is already at 0, so we move I forward again by 1. So now A, perfect match, we go A, we go to B here, but it's a mix match. And then so we look, what's our diagonal? So let's go back to index 2, which is this A right here. So we can start right here at A, B, B. And then that's the end of the KMP algorithm. Alright, so now we are going to look at what are the complexities of each. I put it at the end of the question just so that we can look at the second part here. The complexity of brute force method is m times, do I have caps on? Yeah, I have caps on. Brute force method is big O of m times n. I can't say brute force. It says brute force. Say that 10 times fast. I don't know. I guess I have a speech impediment. Okay, and then for KMP, it is m plus n. Remember that. There's a big difference here. Very, very big difference. One is multiplication, one is addition, and you kind of forget how to do both once you get to like your senior year, but yeah, there are operators that exist. Just remember that. And then how many comparisons are saved here? So when we look at brute force method, we count them all up. Okay, so counting every letter in this table, brute force had 27 comparisons, KMP had 18 comparisons. And so that's a substantial savings, and obviously it just had a lot to do with what type of string we're looking through, but it can be a lot bigger, especially if you look at his examples with if it's just like a 1, 2, 3, 4 and not just 1, 1, 1, 1. But anyways, that's the end of the KMP algorithm. I absolutely destroyed this worksheet. Well, it doesn't matter because now we're going to Floyd Warshall, and it doesn't, and we're just gonna tear up paint now. All right, time for Floyd Warshall algorithm, our second favorite algorithm. I was thinking about it actually, and this is definitely my least favorite. But my least favorite was the knapsack one with the continuous problems. That was before midterm, and I had like that big old graph. Gee, I hated that problem with a passion. Anyways, that's completely irrelevant to anything we're doing right now. I don't know. I just had a headache. But anyways, we're going to do Floyd Warshall, and I'm going to go through a much faster way to do this than the tedious route I took in that first video where I was explaining how to do it. And this is probably way better for you to use on a test. But so we set up our matrices here. If you remember how to set them up, we look at from A to B is 1, A to C is 8, and then A to D is, obviously there's no direct path, so we put infinity, and you kind of continue down that path. And then to initialize this second weird array, if there's a path here, you fill it column wise, 1, 1. If there's a path in B, you fill it with 2, 2. If there's a path in C, you fill it with 3, 3, and all the rest go with this I forget what that symbol's called. But anyway, so that's how you set up the 0. And then now we're messing with 1, we get rid of everything but row 1, column 1, and then diagonal. Diagonal will always say 0. And what we're going to look at is adding we're going to just look at this matrix. We're not going to do like the 3, 2 or anything. We're just going to do this. And we're going to try to add this. So we're going to compare 1. We're going to start with this. And you're going to see what I'm doing here. But we're going to start with 1 here. This column right here. Do 1 plus... We don't have to worry about the diagonal. So we're going to do 1 plus infinity, which is infinity. And so we're just going to carry this value down, which is infinity. So that stays the same. 1 plus 4 here, that's 5, which is better than infinity up here. So we're going to put a 5 here. And then if you remember, now we have to change this table on the right. And the way to change this table on the right is you just set it to whatever k is equal to. K is equal to 1 right now, as you can see this 1 here. So we just put a 1 right there. All right, now we look at this. 8 plus infinity is not any better, so we take 2 down. 8 plus 4 is 12, which is better than infinity. So we put a 12 here. And then we do the same thing. We get rid of this guy here. And we put a 1 right there. All right, and then now, well, these here is infinity, so we're just going to take 9 and 1 down, and that's all going to stay the same. And then now you're done with array 1. Now, you're going to have 2 hours to do this on the midterm, so it's very likely he's going to put like a question like this just to fill up that time. That's just a sneaking suspicion. I have no idea what the final looks like. But anyways, now we're done with array 1, and now we're going to go on to the second, k equals to 2. Alright, now k is equal to 2. We're looking at row 2, column 2, and we're keeping the diagonal the same. So, we don't have to worry about the diagonal. So we're gonna start with this 1 here. So 1 plus, well, no, we can start with here. We can start with this infinity. The infinity is gonna stay the same, so we're gonna bring everything down here. Infinity plus infinity. It's all gonna be infinity. So we're gonna go like this, infinity, and 4. That's all gonna stay the same. We go to 0, we don't mess with the diagonals, we go to 2. Now we look at 2 plus 1 is 3, which is better than 8 here. So we put a 3 here, and we're going to change this over here in our other array to whatever k is equal to. K is equal to 2 right now, so we set this equal to 2. Alright, now we're still at 2, so we do 2 plus infinity. We're not messing with the diagonal. 2 plus 5 is 7, which is better than 12. So we're going to put a 7 here. And we're going to replace this right here with k is equal to 2. Alright. And then last column, we're going to go with 9 here. 9 plus 1 is 10, which is better than infinity. And we're going to do this one, which is, it's just still the same. So we're going to just bring this 1 down here. 1 here. And then now we have to change this value over here to k is equal to 2. And then that's all you have to do for array number 2. And as you can see, this is way faster than the tedious method, which I showed on the first video. Alright, now we're looking at k is equal to 3, row 3, column 3. And we're going to go this way. Now we notice that we have some infinities here, so this one's actually going to be pretty easy. We can just carry these values on down. So this is going to be infinity, this is going to be 4. So yeah, when you know that this column here has infinity right there, you just carry these values on down. You don't have to worry about them. 1, 5. But now we get to 1. So now we have some actual options. 1 plus 3 is 4, which is better than 10, so we're going to put a 4 here. 1 plus 2 is better than 9, so we're going to put a 3 here. And then now those 2 places that we just changed over here can change to whatever k is equal to, which is k is equal to 3. So we're going to put 3 here. And then that's all you have to do for array 3. Yeah, I mean, it's pretty easy. Now our last column here, and this one actually has a lot of math to do. Alright, so we can start with 4. 4 plus 3 is 7, which is better than infinity here. So we're going to put a 7 here. And 4 plus 1 is better than infinity here. So we're going to put a 5 here. And we are going to update these values over here to whatever k is equal to. Oh, I didn't. I erased the numbers. I didn't fill it in. K is equal to 4. So 4, 4, and then we fill in 4 here. 4, and then 4. Alright. Next we're going to do 5. 5 plus 1 is 6, which is better than infinity, so 6 goes there. And 5 plus 4 is 9, which is not any better than 1, so we're just going to keep 1 down here. And then this value over here is going to change to 4. Right here. Alright, and then one last column. 7 plus 3 is 10, which isn't any better than 2, so we keep 2. 7 plus 4 is 11, which isn't any better than 3, so we keep 3. And then that's it. That's your whole array. We have our whole final array here, and then everything to the right here. And then that's all for Floyd Warsaw. And then problem 5, this is just the final review evaluation. I'm not going to sit here and beg for reviews anyways. But that's all we have for end of course review number 2. Again, I'm going to say this for like 4th time. If there's anything wrong in these videos, let me know, and I will go back and fix them. And then this will also help for all the other 100 people that may or may not be watching this video. But again, just please let me know, because I obviously I make mistakes, okay, and I don't want anybody to get questions wrong on the test because I'm doing them wrong in the videos. So if I'm doing them wrong, please let me know. I'm learning these alongside you guys. This is like 6 or 7 of these questions are all brand new to me this semester, so I'm basically taking this class alongside you guys this semester. So I hope you guys understand and cut me some slack here, because I don't know this any better than you. Plus, you guys are attending class, so you know what, you guys better understand this better than me, hopefully. But anyways, again, if you need any help, please let me know. Hope these videos helps you, and I was gonna say it's been a fun semester, but this has been probably the hardest semester I've SI'd for. But anyways, thank you guys for watching. If you have any questions, please let me know. Always feel free to reach out, and I will see you guys, I guess, around PFT if you ever see me around. Wish I had my face cam on, but the camera's still being all wacky, so I haven't bothered with the face cam. But it's better because we had to do the paint. Anyways, I'm rambling. Thank you guys for watching, and I will see you guys if I ever see you around PFT. All right, bye.